So if I factor out an x out of these, I'm left with x minus 2. Factor x out of these, I'm left with x minus 7. And then what, so now on top I have something times something. On the bottom I have something times something. So that means that I have kind of two things being multiplied on top and two things being multiplied on the bottom. Are any of them in common?
You can cancel the x's?
Yeah, I can cancel out the x's. These are not the same, I cannot cancel them. So I'm left with x minus 2 over x minus 7. You cannot cancel out these x's because they're being added or subtracted by with something, right? So they're not, unless they're all being multiplied, you can't cancel anything out from top and bottom. So just leave it right there. That's it. You can't do anything else. The one below, we did something similar to that last class.
That's just you do the x, right?
Right, you just do the x and you factor them. Okay. You do the x in the bottom, you factor them, and then there should be something that cancels out.
And then if there's a number in front of the y on that one, then you have to do the second step with the box?
Right.
Okay.
But we kind of tested you folks on that last exam. So this is more about the dividing from top to bottom. So I'm not going to throw that into this exam. I'm going to leave it where there's no numbers in front of the y. So what he was saying is if there was a 3 in front of that, then things would be different. You have a second step. But here it's just there isn't. So you just have to do the x, two numbers that multiply to -3 and add the 2, right? And then factor that. Okay. Find the domain. Okay, so when it says find the domain, you have a couple problems like that. Find the domain. That means we only care about what's on the bottom. We don't care about the range. So that's just the fact that you can't divide by 0. That's kind of all that we're working on there. Let's look at B. So that means that I want to do B. What can X not be if you work on? We did A already. Let's look at B. So how would you set that up? This can't be 0. What can't be 0?
X squared minus 4.
X squared minus 4 can't be 0. All right, so then figure out, that means you got to factor x squared minus 4. Right? This is a special case.
Okay.
Do you guys remember this one? It's the difference between two squares. Someone remember that one or not?
No.
Well, you can solve it the other way. Just add 4 to both sides and square root both sides. Right? So that you can add 4 to both sides, and then to get x, you square root both sides. Remember, when you square, you have a plus minus. So don't forget that.
Oh yeah, that's what I was doing.
Natalia, are you done?
No, I don't remember.
Okay.
I don't remember.
All right, we'll go over this one. So let's solve this. What's the first thing you do? Add 4 to both sides. So and add 4 to both sides. What do you get?
Yeah, I get it. Yeah.
X squared cannot equal 4.
X squared equals 4.
4.
All right. So then how do I get x?
Is 2. X is 2 because you just
Well,
2 times
okay,
2
but
is 4.
how do you undo a square? Yep, that little, yeah, exactly, Alex. Square root it.
Oh,
Oh yeah.
Mm-hmm. So then x equals what?
2.
2 or
-2.
or -2. There's two possibilities.
Okay.
So everyone remember that one? So for my domain, x can't be 2, and also x can't be -2. Both. Right? It can't be 2, it also can't be -2. So then the asymptote or whole occurs where? If this is what x can't be, my asymptote or whole are where are at x equals 2
Or
and x equals negative 2. Right? Because this is what it can't touch. So what it can't touch is what x equals for the whole, or the asymptote. That's the line it can't touch. All right, so I think you folks need to do one then. Why don't you do D? Do C and D. But quickly, because we have a lot to cover today, and this is supposed to be the easy stuff. So we don't care about this at all.
Okay, that has nothing to do with.
It has nothing to do with the domain at all.
Okay.
Only we care about is the bottom. The rules are you can't what?
Divide by 0.
Can't divide by 0. What else can't you do?
Square negative.
Square root of a negative number. And now we also know you can't take the log of a negative number. So there's no, the only thing you care about is you can't divide by 0. We don't care about what's on top. Whatever. No big deal. You can't divide by 0. Is there a square root here?
No.
So there's no worries about that. The only thing you care about is you can't divide by 0. This does not enter into the domain at all. Has nothing to do with the domain.
Is it the range or no? The top? Or no, it's nothing?
It'll affect the range, but we don't care about the range. We only care about the domain.
Okay.
I'm only asking the domain. All I care about is you recognizing you cannot divide by 0. That's all. So I'm not asking for the range. I'm never going to ask for the range because that's complicated.
Oh,
I'm asking you the simple basic thing of recognize that you cannot divide by 0 and tell me what x cannot be. That's it.
okay.
We're not making this into a giant problem. It's just a small problem. Don't make it into a big problem.
Okay. If it's, when the problem changes, it throws me off. If there's something else in there and then
So
I
that's
just
the
don't
thing.
know
It's
how to do
like,
it.
don't think about, I'm not asking you about the
Yeah.
other stuff.
Right.
You don't have to understand everything about the problem. I'm just asking you to identify what's the domain. That's it. Don't make it into this giant, huge thing. It's just what's the domain. So here, what do we know about the domain? You can't divide by 0, so x plus 1 cannot be 0.
Yeah.
So x can't be what?
Negative 1.
Negative 1. That's my domain. X can't be negative 1. So what's my asymptote of my whole? X equals negative 1. Nice. All right, and the bottom one? What can't equal 0? What can't equal 0, Ryan?
1 or negative 1?
Oh, give me the x squared minus 1 can't equal 0. So then,
Yeah, sorry. And then x squared equals 1.
So x equals, or can't equal what?
1.
Or?
Negative 1.
Now I'm going to write them separately so that people get used to writing them separately for the asymptote or whole.
Oh, you want 2 lines like that?
Yeah, I
Does it
do want
really
2
matter?
lines.
Or can I just put x equals 1 or negative 1?
Well, for this one you can, but the asymptote or whole, when you have an equations of an asymptote, it's an equation of a line. Oh, sorry, it's not equals, it's like equals. So the line is not, you can't have y equals 1 comma negative 1. X equals 1 is a line. It's a line that goes like that. X equals negative is a number goes like that. You can't have an equation of a line that x equals 1 comma negative 1. You have to write them separately.
Okay. You can't put or. You just have to do.
Right, you can't put or. Okay, so we did this last class. Do we need to do it again? Yes? Okay, so I want to take a look at A, find the domain and the range, and the vertical and horizontal asymptotes. I would say sketch the dots, dot your lines in first. Dot in your asymptotes. I'm not worried about that one. Let's just focus on this one. Well, did I ask you that or not? I don't even know. So work on these two. Here, I'll go over this one with you when I do that. So here, I see sort of an asymptote here. Does anyone see that?
Oh, that, oh, yeah.
So, but my domain, x could be anything. So here, my domain is negative infinity to positive infinity. My range, my y's only go from 1 to 2. That's doesn't ever go higher than 2 or lower than 1. So it's from 1 to 2. I cannot touch 1, but I can touch 2. So I have no vertical asymptote, but there is an asymptote that goes along here. So what stays at 1 this whole time? X or y? What's 1 this whole time? Is my x1 along here, or is my y1 along here?
X.
This is x.
Not Y.
Y equals 1. So that's kind of the harder one. I'll do that one, but you folks do this one over here. And again, I would say put in the dashed lines for the asymptote first.
Pushing that down.
So did everyone draw in the asymptotes? The dotted lines? So the dotted lines should go right through here. Yeah, and right through there. Everybody has them? So what's my domain? Everything except for what?
-1.
Yep, x can't be -1.
Oh, that's the domain.
What's my range?
2.
Y can't be 2. Now if you had done, it's also okay, Eric,
Oh,
if you did negative infinity
yeah, that's what I was trying to do.
to -1, union with -1 to positive infinity, you can totally do that also.
Okay.
That's the same thing. And for the range, you could do y can't be 2, or you could say from negative infinity to 2, union with from 2 to positive infinity. That is also totally acceptable. Good. What's my vertical asymptote? Vertical goes, okay, let's do the horizontal. Horizontal goes what direction?
Right to left.
Yep, left, right, yep, so that's this line here, so it's something equals 2.
Y equals 2.
Yep, y equals 2, because we have y does equal 2 up here, so it's y equals 2 there. What's my vertical asymptote? The up-down one?
X equals -1.
X equals -1. So that should be negative. Good. All right. Now, did we do 16 last time?
No.
Okay. So 16. So remember, it says exponential. Everyone see this where it says exponential?
Exponential function, yeah.
I gave it to you right here, but I might not in the exam. However, the front of the exam, you should look, and the front of the exam will say exponential, y equals c times a to the x. So every time you see something that says exponential, or log, or inverse, or direct, flip to those formulas at the very front of the exam, and it'll say exponential, y equals c times a to the x.
Oh, okay.
So then you'll say, oh, exponential, y equals c times a to the x. All right, so then what's up with c? C is my what? C is. I'm gonna see a different color. C is what? Does anyone remember what c is for an exponential function? It's my multiplier. It's also known as my y-intercept. And it's also known as my initial amount, or starting amount. What's A? A is my, anybody?
That's a growth or decay.
Yes. it's my base, right, the exponent. It's also known as my growth factor, growth or decay factor. I'll call it growth because if you're just decay, we kind of go along with it. Everybody feeling all right with that?
That part, yeah.
So here, A is my base, X is my exponent, C is my initial amount, Y is my answer, kind of in a way, right? Okay, so so the first one, I'm asking to find f of 0. Is f of 0 my x or my y? F of 0.
X.
No.
X, I said.
F of 0 is my y.
Oh, the whole thing, yeah, the
F of 0 is my y.
X, yeah.
What's x?
0.
X is 0. Does that make sense?
No, well, that's what I was trying to say, but I missed it.
Okay, yeah. So f of 0 is my y when x is 0. So what's my y when x is 0? Everyone find it. This is y. So what's y?
4.
Yep, 4.
How did
Did
you
we
do-
see that?
No, I don't know what we're doing.
Eric. So when x is 0,
Oh, you're just looking on the ground.
What's y?
Okay.
Yep.
Oh, okay, I gotcha. I was trying to figure out some equation with this y
Nope.
equals CAX
Nope.
and trying to plug
Yeah.
in the 0.
Right.
So,
Okay. So that means that my c is what? What's my y-intercept here?
0, 4.
0, 4, yep, so 0, 4. And so this is also known as 0, comma, C. So wherever you hit it, my C is that same number. So what's my C?
4.
4. Yep, that's my initial amount. That's where I'm starting off at. What's f of 1? Here it is. Does anyone see that spot? What's this point?
8?
Yep, 1, comma 8. So f of 1 is
8, 8.
8. Great. So now I can't. A is not 8. I've got to put in my equation for this one. So far I start off with y equals c times a to the x, and then I find that c is 4. So now I have y equals 4 times a to the x. Everybody okay with me on that part? All right, so now we have a new point. We know that when x is 1, y is 8. Put those in and solve to find a. So we're going to substitute in the point 1, comma 8 into, this is 1 point, 1 moment in time. I can use that 1 moment in time and put that in for x and y to solve for a. Everybody do that. You did one of these on your homework. All right, so I think folks seem like they have this. We've got 8 in for y. Remember, this is just at 1 point. X and y along this whole thing change, but at this 1 moment, y is 8 and x is 1. All right, then you folks all figured out that, okay, I'm multiplying 4 by this, so I should divide both sides by 4. So then I'll get 2 equals a to the 1. The a to the 1 is just a, right? So a is 2. So then my equation is y equals c. What's my c?
4.
Times a. What's my a?
2.
To the x. Done. And that's our whole goal. Our whole goal, like for a line, our goal is to find m and b. Right? Y equals mx plus b. Everyone remember that?
Mm-hmm.
So if you find m and b, you're golden. Here, y equals c times a to the x. You find c and a, you're done. Perfect. You got it. So this is not hard. All of you folks got this. The trouble is remembering it, right? Because you've seen it a couple times before. People are like, what? What do I do? So you just have to make sure that you remember how to do this because the procedures are pretty straightforward. And I feel like you all, like, once I kind of guided you in the right direction, you're off and you got it. But I'm not going to be there to guide you on the exam. So you got to make sure that you kind of remember kind of those pieces. Does that sort of make sense? And we do sort of guide you. We tell you, we prompt you for f of 0. So then we tell you can find c from that. Right? And then we prompt you with f of 1, and then we kind of tell you somehow you should be able to find a from that. So you're given some sort of hints along the way. So hopefully when you see this in the problem, you'll say, oh, f of 1 is 8. Okay, so somehow that's supposed to help me figure out what a is. Just you plug that into your formula so far. All right. This one, remember, skipping 17, so that's not going to be on the exam. This one will be on the exam. All right, so how do I know if it's linear or exponential?
Linear goes up by a set amount.
Linear goes up by a set amount by adding a set amount each time?
Yeah.
And someone else, exponential goes up by what? Exponential goes up by whatting a fixed amount each time. Gabe? So let's go back to y equals c times a to the x. This is my exponential. And Ryan, you had said that a represents what?
The growth and decay, or growth factor.
Growth and decay, what's the word after that?
Factor.
Factor. The growth and decay factor. So exponentials go up by a factor each time. Factor means what? Multiply. Exactly. So we're multiplying by that same amount. We're multiplying by a each time. So here, am I adding the same amount each time, or am I multiplying by the same amount each time? As I go up, 5, 10, 15, 20. Adding. We're adding how much?
5.
Yep. So this one is exponential or linear? Linear. Why? Explain how you know. We're adding 5 each time. Okay, how about this one here? Here I'm adding 2. Here I'm adding 3. Well, that's not right. This is not the same amount each time. So they can't be linear. So maybe I must be multiplying or dividing by the same amount each time. How do I get from 4 to 6? What do I multiply by? If you're not sure, then just do 6 divided by 4. I would do 6 divided by 4.
Oh,
1.5?
yeah.
Okay, so to get from 4 to 6, you multiply by 1.5. Will that work if I do 6 times 1.5, will I get 9?
Yes.
If I can do 9 times 1.5, will I get 13.5? So this is going to be exponential or linear?
Exponential.
Yeah, exponential. Why? You got to say why. If you don't write down why, then you're going to lose. You're not going to get full credit on this problem.
You're multiplying by 1.5 each
Yep.
time?
Multiply by 1.5 each time. All right, now, then you might have an extra credit question that will ask you, write the equation for each of these. Well, here, I'm adding 5 each time, so that means that my slope is 5, so I'm going to have y equals mx plus b, right? So y equals I'm adding 5, so it's 5, oops, it's supposed to be purple. 5, x plus, and then my b is my initial amount. So remember that for linear? M is your slope, how much you're adding each time. B is your initial amount, what you start with. What am I starting with?
0.
Nope. X is 0, y is,
Oh, you're saying it's
yeah. When x is 0, what's y? So my starting amount is, my initial amount is when x is 0, your initial amount is your y-intercept. It's the amount when x is 0. So x is sort of like your time. When x is 0, when my time is 0, what's my y? So when my time is 0, my y is 5. Does everyone see that up top? Here, what's my initial amount?
4.
4. Someone see that one? So for here, my equation would be y equals my initial, remember c times a to the x? C is my initial amount. What's my initial amount again? 4 times a, what's my a? What's my growth factor?
1.5.
1.5 to the x. So remember, the equations will always have a y equals something with x in it. We're never going to have a multivariable, so we're always going to have y equals something with x in it. All of our equations, those will be. Now, if you are not sure about this stuff up top, that's the important stuff. This is just the extra credit. Don't worry about that unless you're, unless you're solid on this. The top part is the important part.
Linear b is the growth factor for the linears. B equals the growth factor.
For linear, the slope is there is no growth factor.
Oh, what's b then?
B is your initial amount.
Oh, initial amount.
Mm-hmm.
And then m is how much you're adding.
Yeah, your slope, how much you're adding.
So slope.
I'll let you folks do the last one on your own. Solving for x. So we did some of these, right? Let's take a look at number 4. Or yeah, we can do one. We'll do one. What's x? So what's my base?
X. No.
Let's do 3 first. What's my base?
Oh, 4.
Everyone look at this. Everyone write down the base. Rewrite this in exponential form. What's my base? I want to write down the base. Write it down. Alex, write it down. Okay, everyone, what's the base?
4.
4. Great. What's my exponent? Everyone write down the exponent. Write it down. Put it in the exponential spot. What's the exponent?
3.
3. What's the answer? Equals. What's the answer?
X.
X. Good. So then what's x? That's not your calculator. 4 to the 3rd.